believe it's a blank question. We're going to look at what are some of the more difficult questions that sometimes come up. It's just the wording in the question. Some of them aren't necessarily that much more difficult, but sometimes they ask you to find the last term. So if you had 2x plus y to the 7, you'd have to know that there's 8 terms, and then I'm finding the last term, right? Or if this was 2x plus y to the 10, if you're finding the last term, then you're finding the 11th term. Sometimes they'll ask you to find the middle term. So if I had 2x plus y to the 10, there would be 11 terms. Does it make sense that the middle one would be term 6? And sometimes there's not a middle one. Like if you only had 8 terms, there wouldn't be one in the middle because there's 4 on this side, 4 on this side. It only works that there's a middle term if you have an odd number of terms. So in 2x plus y to the 10, there would be 11 terms. Then your middle term would be the 6th one. 5 on either side, and that 6th one would be right in the middle. And then there's ones that say, find the term containing. And that's what we're going to look at next, is ones that say find the term containing. If you do an expansion of this, one of the terms has an x to the 7. Which one is it? And what does that term look like? And similar to the find the term containing is a question that might say find the constant term. And a constant term means, if you think back to the definition of a constant in math, that has no variables. So in other words, it's finding the term containing x to the 0. So our first example in looking at these, find the term containing an x to 9 in the expansion of 3x squared minus 2 over x to the power of 9. So again, we have a couple of options. It's to the power of 9. There's going to be 10 terms. You could find all 10 terms, simplify them, and one of them is going to have an x to the 9, and that will be your answer. But if I find all 10 terms, that's going to take a little while. So if I try to use my formula, right, term k plus 1, n choose k, a to the n minus k, and b to the k, and I try to plug in everything that I know. Well, I know that n is 9, but I don't know which term it is, so I have to leave that as a k. And I know that a is 3x squared, and this is going to be 9, but I don't know what k is, so it's 9 minus k. And b is negative 2 over x to the k. What else do I know? I know that when I find my answer, it has an x to the 9. So my term k plus 1, I'm just going to go, it's going to be something x to the 9. I need to find out what k is. And the way that we can do that, and you'll actually write this when you're solving a question like this, temporarily ignore all the coefficients. Coefficients are the numbers in front of variables. Really, the only information that we want to look at is our powers with our base and our exponent. So that means on the left-hand side of my equation, I'm only thinking about the x to the 9. And on the right-hand side of the equation, well, 9 choose k will be a number, so I'm going to ignore it. 3 to the power of 9 minus k is going to be a number, so I'm going to ignore it. But I do have a power here. I'm going to have x to the, if I multiply the 9 minus k times the 2, I'm going to have x to the 18 minus 2k in my numerator. And in my second fraction, I'm going to ignore the negative 2, because it's just a number. But in my second fraction, I have some x's that will be in a denominator. How many? X to the k. So I'll get you to write this out, then we'll think about it and explain it again. What we're doing is we're ignoring all the numbers in front. We're just going to use the powers to help us solve for k. I know my term has an x to the 9. According to my formula, I have x's from my first term and x's from my second term. It would sure be easier if they just had x's in one spot. You could figure it out right away. Using my exponent laws, x squared to the 9 minus k becomes x to the 18 minus 2k. And x to the k on the bottom will just become x to the k. So this is just looking at my exponents and my powers. At this point, some people like to guess and check. Some people like to use algebra. Right? So if you're guessing and checking, you could say, I think k is 3. Oh, I shouldn't pick it right off the bat. Okay, I'll pick one wrong. I think k is 4. If you tried k is 4, how many x's would you have on the top? 18 minus 8, you'd have 10. How many x's would you have on the bottom if k is 4? You'd have 4. What does that simplify to? X to the 6. Oops, it's not quite right. I need k to be something a little bit smaller, because I want less of them to cancel out. So then you try 3, which I tried to accidentally pick the wrong one to begin with, and I picked the right one. Can you see if k is 3, you would have x to the 12 on the top, and an x to the 3 on the bottom, and that simplifies to give you an x to the 9. So that's using just try numbers to figure out what works. If you wanted to solve it algebraically, and I have seen on a final exam that say you have to solve it algebraically, what's your exponent law when you divide? What do you do to the exponents? When you divide powers with the same base, you would subtract the exponents. And then you'd have x to the 9 equals x to the 18 minus 3k. This is where we went, so 9 would have to equal 18 minus 3k. Move the 3k to this side, the 9 to this side, divide by 3. And we can solve what k is equal to. If k is 3, we can now find out term 4. Because term 4 is when k is 3. The question said, find the term containing x to the 9. It's going to be term 4. And choose 3 now. 3x squared to the 9 minus 3, and negative 2 over x to the 3. So go to our calculator. 9 choose 3 is 84. 3 to the power 6, this will be 729. X to the 12. Negative 2 cubed will be negative 8 over x cubed. So when simplifying, simplify each of the three separately, and then you can multiply your numbers together. So we have 84 times 729 times a negative 8, negative 489,888, and the x's simplify to give you x to the 9. So to recap what we've all done here, the question asked, wow, that was small. Find the term containing an x to the 9. So what do? We put everything we knew into our formula and realized we don't know the number in front of the x to the 9. That's what they're asking us really to find. Find the term with the x to the 9, but we don't know what number's in front. So we temporarily ignore all the numbers in front and just think about our powers. And I recommend taking your formula and writing it right as a fraction right away if there's more than one x. Then either guessing or checking or using your exponent laws, you solve for k. Once you find k, then you can go back to your regular formula and find the actual term. So we're going to do one more example. And in this example, an above constant term means there's no x's, so we're going to write x to the 0. In the expansion of five x cubed minus 2 over x to the 12. So again, I'll write out the formula here from your formula sheet. What do we know? We know on this side we have some term with no x's, so we write x to the 0. On this side, n is 12. We don't know k. A is 5x cubed, 12 minus k. B is negative 2 over x again to the k. So this question is just a tiny bit harder because you have to know terminology that constant term means x to the 0. Once you know that, it's identical to the one we just did. What did we do next? We temporarily ignored the coefficients. So what would that leave us with? On the left side, we have no x's. On the right side, we're going to have, in our numerator, can you see that you're going to have x to the 36 minus 3k? And in your denominator, an x to the k. If you like to guess and check, I suggest trying 9. Oh, it works. If you don't like to guess and check and would like to use the algebra says when I'm dividing, I subtract my exponents. So I would have x to the 36 minus 3k minus another k will be minus 4k. So 0 has to equal 36 minus 4k, move the 4k over, divide by 4, and you get k is equal to 9. So that tells us if we want to find the constant term, we need to find term 10. Term 10 equals 12, choose 9, so k is 9, 5x cubed to the 12 minus 9, and negative 2 over x to the 9. Go to our calculator for each of these. 12 choose 9, 220. Oh, and the question you need to do for this one is number 9. 220, here you would get 5 cubed, which is 125, x to the 9. And here you would get 2 to the power of 9, negative 512 over x to the 9. Notice your x to the 9s all cancel out. And when we multiply this all out, we get a number without any x's. That makes it a constant term.